We are going on with our series on complex numbers, and in this tutorial we'll focus on solving equations with complex numbers as results. And we will do two examples. So in our first example we have 2x squared is equals to negative 72, and what we want to do is solve for x. So first I'll rewrite the equation in standard form by bringing 72 to the left hand side of the equation. Now I notice that there's a common factor of 2, so I can divide everywhere by 2. So that is equals to x squared plus 36 equal to 0. Normally you would not be able to factor this expression because it's not a difference of two squares. What we can do is rewrite plus 36 as negative 36 times I squared, where I squared is equals to negative 1. So we'll have x squared minus 36i squared, which now is a difference of two squares. And when I factor that, I have x minus 6i times x plus 6i. So I have two possible solutions for x by setting each of these parentheses equal to 0. So x would be plus or minus 6i, where I is equals to the square root of negative 1. So our result is not a real value, but two non-real values for x. In our next example, we'll look at a trinomial. So let us say that we have x squared plus 4x plus 12 equal to 0. Now again, we cannot factorize this trinomial. So let us use the quadratic formula, which is x equals to minus b plus minus the square root of b squared minus 4ac divided by 2a, where the a value is equal to 1, the b value equals to plus 4, and the c value equal to plus 12. So when I substitute, I have x is equals to minus 4 plus minus 4 squared, which is 16, minus 4 times 1 times 12. And I take the square root divided by 2 times 1. So when I simplify, I have x equals to minus 4 plus minus the square root of negative 32 over 2. Now normally you would not be able to find the square root when it has a negative value on the inside. But what we can do is use the imaginary number of I as the square root of negative 1. So that means that I can solve for x by having negative 4 plus minus the square root of 16 times 2, which is 32, times negative 1 over 2. Now if I simplify the square root only, I have plus minus 4, because the square root of 16 is equals to 4. Then I cannot find the square root of 2, so I'll have the square root of 2. And the square root of negative 1 would simply be I. And that's over 2. And now when I divide everywhere by 2, I have two possible values for x, which is x is equals to negative 2 plus minus 2 square root 2 times I. So again, my result is not a real value, but a non-real value using I to represent the square root of negative 1, which allows me to find two possible values for x.